In this problem, we are given two integer arrays, nums1 and nums2. Our task is to find the maximum dot product between two non-empty subsequences. One chosen from nums1 and one chosen from nums2. What does dot product mean here? If we pick two subsequences of the same length, the dot product is calculated by multiplying corresponding elements and summing them up. Example: if the subsequences are a, b, c, and x, y, z, then the dot product is a asterisk x plus b asterisk y plus c asterisk z. What is a subsequence? A subsequence is formed by deleting elements from the array without changing the order of the remaining elements. Valid subsequence: 2, 3, 5, from 1, 2, 3, 4, 5. Invalid subsequence: 1, 5, 3, order changed. Important constraints. The subsequences must not be empty. Both subsequences must have the same length. We must return the maximum possible dot product. Why is this problem tricky? Numbers can be negative. Sometimes the best answer comes from picking just one pair. We cannot assume longer subsequences always give better results. Greedy approaches fail. This problem requires dynamic programming. Example walkthrough. Example 1. Input: nums1 equals 2, 1, minus 2, 5. Nums2 equals 3, 0, minus 6. Goal: we need to pick non-empty subsequences from both arrays with the same length, such that their dot product is maximized. Let's analyze possible choices. From nums1, 1 good subsequence is 2, minus 2. From nums2, the matching subsequence is 3, minus 6. Now calculate the dot product. 2 times 3 is equal to 6. Minus 2 times minus 6 is equal to 12. Total equals 6 plus 12 is equal to 18. This is the maximum possible dot product we can form. Output: 18. Example 2. Input: nums1 equals 3, minus 2. Nums2 equals 2, minus 6, 7. Key observation: even though we can pick longer subsequences, sometimes picking just one element gives the best result. Best choice: from nums1, 3. From nums2, 7. Dot product: 3 times 7 is equal to 21. Trying longer subsequences here actually gives smaller results. Output: 21. Example 3. Input: nums1 equals -1, minus 1. Nums2 equals 1, 1. Important edge case. All possible dot products here are negative. But remember, we must choose a non-empty subsequence, so we cannot return 0. Best possible choice: from nums1, -1. From nums2, 1. Dot product: -1 times 1 is equal to -1. This is the maximum value we can achieve, even though it's negative. Output: -1. Key takeaways from examples. We are free to choose any length, but both subsequences must match. Sometimes shorter subsequences give better results. Negative numbers make this problem tricky. 0 is not allowed unless it's formed from valid subsequences. This is why we need dynamic programming to explore all valid states efficiently. Today we're solving LeetCode 1458, max dot product of two subsequences. We're given two integer arrays, and our task is to choose non-empty subsequences of equal length from both arrays such that their dot product is maximized. This problem is tricky because the arrays can contain negative numbers, which means we cannot rely on greedy approaches. The key difficulty here is that skipping everything is not allowed. Even if all products are negative, we must still pick at least one pair. That immediately tells us this problem needs dynamic programming, because at every position we must carefully decide: do we take the current pair, or skip one element and try later? Let's define our DP state clearly. DP, I, J, represents the maximum dot product we can achieve using elements from nums1, I happy smiley, and elements from nums2, J happy smiley. In other words, it answers What's the best dot product we can form starting from these two indices? At every position, I, j, we have three choices. Option 1. Take both elements. Multiply them and move both pointers forward. Option 2. Skip the current element in nums1. Try pairing nums2, j, with a later element in nums1. Option 3. Skip the current element in nums2. Try pairing nums1, I, with a later element in nums2. We compute all three and store the maximum result. To avoid recomputation, we store results in a memo table. Important edge case. There's one very important edge case. If one array has only negative values, and the other has only positive values, then the best answer is simply the maximum possible single pair product. Without this check, DP would incorrectly return 0, which is invalid because subsequences must be non-empty. Final result. After setting up memoization and handling edge cases, we call our recursive function starting from 0, 0. This guarantees all valid subsequences are explored. The best dot product is found efficiently. And that's how we solve this problem optimally using dynamic programming. Let's run the solution with the provided test cases. Submitting the code to LeetCode. And boom. Accepted. All test cases passed successfully. If this explanation helped you understand a tough DP problem, hit like, subscribe, and share it with your friends. I'll see you in the next LeetCode breakdown. Happy coding!